Okay, so we are in chapter 5, and I actually am excited that we're doing this before the test because these first two problems are stuff that we did back in chapter 4. So I think this is a nice little easy warm-up for us today. We're in our identities section. So honestly, for the next few lessons, we will not even really use a calculator. We're doing a lot of stuff by hand, okay? It's going to be a little confusing at first because I have to give you some tools in order for you to know what to do with anything. So I need you to just kind of be okay being uncomfortable. But we will start with some that I think that you should know how to do. So these first two, say find the trig function. So number 1 says find sine and cosine. If tangent of theta is equal to 3/4, and then sine, and this got cut off. Let's say that sine is greater than 0. Sine is greater than 0. So this is like the last test where there were just a ton of like triangles. You drew a triangle, you found the missing side. We could find any trig function. Let's figure out which quadrant we want to draw this in. If it says tangent is positive 3/4, what quadrants could that be in? 1 or 3. And then it says sine is greater than 0. Does that mean it's positive or negative? It's positive. Good. Where is sine positive? 1 and 2. So which quadrant should I draw this in? Q1. Q1. So we're going to start by drawing this in Q1. This seems familiar enough right now, right? Okay, perfect. Like, oh, this is a new chapter. It feels like the same. I've got my theta, I've got my right angle, and now I need to use that 3/4. Tangent is what over what? O over A. O over A. So we've got our O of 3, we've got our A of 4. And then now we can use Pythagorean theorem to find our hypotenuse, right? Let's do it. 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared. 5 equals x squared square root. Nice. We love a nice. We love a whole number as my answer. Now I've got my triangle figured out. Are any of those parts, should any of those be negative? Did I mislabel anything yet? No. It's all good, right? All positive. Perfect. Okay. Now using that triangle, let's label our sine and our cosine of this. So sine of theta is going to be 3/5. Is that good to you guys? And then cosine theta is 4/5. Right, that wasn't too bad, was it? Can you do the next one without me? Can you start the next one without me? What's the chance? Great question. I think it's less than 0. Tan is less than 0. Make that tan less than 0. See if you can start that one without me. I'm not trying to guess it. But I've got my triangle up on the board. I've got it labeled so far. I just have to go do my Pythagorean theorem. Double check, make sure you're on the same page. Keep rolling if you're doing good. How did I look up?
Because it's a negative, right?
Good. You knew I was good, ready to add that one, didn't you? So even knew that I couldn't just write 3 on there. I gotta write -3 because we're going down. Now that I've got my OA and H, it says give us our sine and tangent, so I'm gonna go do that really quick. Sine of theta equals -3/5. And tan of theta equals -3/4. The negatives are super important in there. Make sure you have them. All right, not a too crazy start for this chapter, is it? Guys doing good? Okay, we'll get a little crazy now. So I told you might want to scrap piece of paper out. So I want you to get that out now, and we're gonna label it trig identities. Don't worry about it being messy or crazy. I'm gonna give you a sheet later. But I wanted you to create it on your own. I think that there's some power in you writing it down and coming up with it and making sure that you copy it correctly. So just a scrap piece of paper, or you can even do it on the back of that unit circle quiz thing that I gave you, wherever you want to put it. And I want you to label it trig identities. I'm actually gonna go a step further than I did with alpha, and I'm gonna label this first set reciprocal identities. First one is gonna be reciprocals. And I'm gonna have essentially 8 of them. I'm kind of setting myself up a little grid just because this is who I am. Know yourself. Okay. I'm going to argue that most of these you already know. Like these should not be a big surprise, the ones that I'm about to write with you. Okay. The thing about the reciprocals is I have our 3 normal trig functions I taught you back in geometry, right? Sine, cosine, tangent. This year I taught you 3 new ones that were the reciprocal of those. If you remember sine, what's sine's reciprocal? Cosecant. So sine is the same thing as 1 over cosecant. And cosecant is the same thing as 1 over sine. That's what we're about to do with all of these trig functions. So I'm going to write all of them and they're reciprocal. So sine is the same thing as 1 over cosecant, and cosecant is the same thing as 1 over sine. That's not really brand new information, is it? We should kind of know that a little bit. Next one I'm going to do is cosine. That's 1 over secant. And so we know secant is equal to 1 over cosine. And then last one, tangent. It goes with cotangent, so it's 1 over cotangent, and then cotangent is equal to 1 over tangent. Now you'll notice I've got a blank line here, and that's not done unintentionally, that's done on purpose. I have another thing that I want to write for tangent and cotangent. If you notice, sine and cosine and secant and cosecant can all be written in terms of sine and cosine, right? But tan and cotangent are kind of their own thing. I want to write tangent in terms of sine and cosine. take your brain back to the unit circle. Tangent is what in terms of x's and y's in the unit circle, Ava?
Y over X.
Y over x. Now, on the unit circle, what does y mean? Y is your sine, good. So if tangent is y over x, tangent also can be thought of as sine over x, which is cosine. Isn't that cool? Cosine. What's cotangent gonna be then?
It's cosine over sine.
Very good, we're gonna flip that, reciprocal. Now I have every single trig function that can be written in some kind of terms of sine and cosine, okay? That is what we want to see. I'm gonna do this a little bit different than I did with alpha. I'm gonna teach you one more method and then we'll do some practice, okay? What I'm essentially building is tools in your toolbox. I'm giving you a hammer, I'm giving you a power drill, I'm giving you a screwdriver. You don't really know what we're doing with them yet, but I'm giving you all these tools, okay? The next one I'm gonna do, I could prove this out to you, but for sake of time and probably of interest, I'm not gonna prove it all the way out. I'm just gonna tell you what it is. I'll kind of prove the other ones after this. The next one is sine squared theta plus cosine squared theta equals 1. Anytime we see sine squared theta plus cosine squared theta, that is the same thing as 1. Okay, I'm gonna write some stuff underneath that, but I'm not going to yet. I think that's enough of a bone to throw you guys right now. So right now, these are all the tools that we have. What we're about to do is go back to our notes. So I'll kind of split screen, or actually I might even get rid of my trig identities because you have all yours on your paper. I'm gonna use these tools and we want to simplify what was given to us all the way down to either hopefully one trig function and hopefully no fraction. So that's the goal, is you want to simplify it down to just one trig function. Okay. Is anybody still writing my trig identities, or can I get rid of that screen right now? Okay, I'm gonna move it, just so you can kind of see all the things I'm writing with. Okay, so we're simplifying, we're gonna start with 2a, okay? I've got tan x times cosine x. One first good way to start when you're simplifying is get everything in terms of sine and cosine. Can you rewrite tangent in terms of sine and cosine? What is it?
Sine over cosine.
Good, so tangent is the same thing as sine, and I'll just make it x, just kind of stick with the problem. Sine x over cosine x. Cosine is already in terms of cosine, so I don't need to rewrite it. So I'm just going to say times cosine x. You could even make it over 1 to help us with all of the fractions. And now we're going to see if we can simplify or factor or do any of those things. Can you do anything here?
You can cancel the cosine.
Good, my cosines can cancel out. What am I left with? Sine x. Is that one trig function? Without a fraction? Yeah, that's simple. That's as good as it gets. So that is my simplified version. Cool. Let's actually skip down to letter D. I'm going to do letter D next. We're going to do the same thing. Can we rewrite that in terms of sine, cosine, blah, blah, blah? Good. I'm going to make sine x be sine over 1. Tangent x is going to become sine x over cosine x. We just talked about that, right? And then cotangent on our identity sheet, we know that is cosine over sine. All I did was rewrite tan x as sine over cosine. I rewrote cotangent as cosine over sine. Now, you could get those fractions in that parentheses with like denominators, add them up. What I would rather do is I'm going to distribute that sine, bless you, to everything. So I'm going to multiply each of those by sine. When I multiply sine over cosine times sine, I'm going to get sine squared x over cosine x. Okay, you good with that? Sine over 1 times cosine over sine. Those signs are going to be able to cancel out, and so I'm just going to be left with cosine. All right, we multiplied it through. We're not done yet, right? There's still a lot going on. I wanna add these two things together. What am I gonna need to add these two things together?
Like terms.
Like denominators. This is essentially cosine over 1. What do I need to do to that second fraction to get it to have like denominator?
Multiply like this.
Multiply by cosine. So that's gonna give me sine squared x plus cosine squared x. Both of my denominators are cosine now, so it's all over cosine. Oh shoot, does this look like something on our identity sheet? What do you see, Ryan? What's just one?
Sine squared.
Good. Our identity sheet says so sine squared plus cosine squared is just 1. So I'm gonna replace the whole numerator with just 1 over cosine. I want you to go one more step farther. What is the same thing as 1 over cosine? Secant. Good. So my final answer here is secant x. I can actually just rewrite that so it's not messy. Good. All right. Before we do a few more, I want to teach you a few more identities. Are you guys ready to go back to your identity sheet? Now you kind of see what we're doing and why we're doing it, right? You're kind of buying into our process. Okay. Now, I want to manipulate this formula a little bit. Let's start by just getting other things by themselves. So right now I've got sine squared plus cosine squared equals 1. What happens? Don't write this down. That's why I'm going to write it really light in yellow. What if I minus cosine squared from both sides? What would I get? What would be left? What would my new equation be? Sine squared, right? Sine squared by itself equals what? 1 minus cosine squared, right? That's all I wanted there. So we could rewrite it, we could manipulate it, so we could minus that cosine squared from both sides. So anytime we see 1 minus cosine squared, that's the same thing as sine squared. Okay. Let's do one more manipulation. Let's minus sine squared off of both sides to get it in terms of cosine squared. So that would be cosine squared equals 1 minus sine squared. We could see it in different ways, so I like to kind of make note of all the different ways that I could visualize this, different ways that I could see it. So those are all tools that we're allowed to use and allowed to replace, okay? Now, I'm gonna manipulate it even farther to give you a new set of identities. So I'm gonna give you essentially 6 more, but we'll start with just 3 more right now. That's such a bad box, it won't even fix it. So now, in order to get my green equation, I'm gonna actually divide all of these terms. We're gonna divide by sine squared. If you do something to every single part, it still counts as an equation. So I'm still using my original equation. I'm allowed to do this. What happens if I divide sine squared by sine squared? What am I left with? 1. I'm left with 1. What's cosine squared divided by sine squared? What's cosine divided by sine?
1 over.
Cotangent. So if I now have squares in here, it's going to be cotangent squared. And then what's 1 over sine squared going to be the same thing as? Not tangent. What's 1 over sine? It's cosecant. So it's going to be cosecant squared. So this is my base for my new one. I'm going to erase these little dividing by. This was just how I proved it. I wanted to show you that I didn't just make this up. This is why it goes together. Okay. Just like the last one, can you manipulate it so we get each part by itself? So like if we were to like minus that cotangent squared from both sides. If I were to minus cotangent squared, I get 1 equals cosecant squared minus cotangent squared. And if I minus 1 from both sides, I would get cotangent squared equals cosecant squared minus 1. Again, I just like to write it these different ways just because you may see it different ways, but they all are the same equation, same formula. All right, let me give you one more box of these, and then we'll go back to our problems, okay? I just divided everything by sine squared. What do you think I'm gonna do now to get another set of, good, we're gonna divide by cosine squared. Don't write this purple thing on here. I'm just proving to you what I'm doing. So now I'm dividing everything by cosine squared. What's sine squared divided by cosine squared? What's sine over cos? That's tangent. Very good. Tangent squared. I'll put him down here just because I'm running out of room. What's cosine squared divided by cosine squared? Just 1. And what's 1 over cosine squared? Secant squared. So again, I'm kind of deriving this by dividing by sine squared from everything, dividing by cosine squared from everything. Now I'm gonna manipulate these so I'm able to move everything to each side. So let's say I minus 1 first, I can get tangent squared theta equals secant squared theta minus 1. And then let's say I minus tan squared, I get 1 equals secant squared theta minus tan squared theta. That's really all the tools I'm going to give for you today. What we're about to do is go back to our other sheet and use these tools to see if we can simplify. You guys doing okay so far? All right. All right, I'm gonna put this away. I'm gonna get this bigger. All right, let's go to letter B. All right, 1 plus tan squared over cosecant squared. Does any of that look like anything on our identity sheet?
The 1 plus the tan squared, wouldn't it be secant squared?
Good, our sheet says that's the same thing as secant squared. So I'm gonna replace that as secant squared. Now I've got secant squared over cosecant squared. Yeah, there's cosecant squared and secant squared on my sheet, but I literally just got secant squared by getting rid of that plus, and I would love to just keep it there. Now I'm gonna think about, can I put it in terms of sine and cosine? So can I make secant in terms of sine or cosine? What's secant squared the same thing as? 1 over cosine squared, good. What about cosecant? What's that the same thing as? 1 over sine squared. Very good. We've got this big ugly fraction, but we've been doing this for a long time. We can just multiply by the reciprocal. So I'm going to come down here and I'm going to rewrite that numerator 1 over cosine squared. And I'm going to multiply that by the reciprocal of the denominator. So it's going to be times sine squared over 1. Okay. Can I do any canceling here? Nope, and that's okay. We're just gonna multiply them together. I've got sine squared x over cosine squared x. And sine over cosine is the same thing as tangent squared. Good, and there's no fractions there. It's just one trig function. We did it. We doing okay with what I know this is brand new and I know it's kind of weird, but you guys feeling okay? All right, let's keep rolling. Let's look at letter C. Sine squared of negative x plus cosine squared of negative x. Does this look like anything on our identity sheet? Not even that. Why do you say -1?
Well, Cause like. I just thought like, there's like a finger on there. Maybe go on the thing.
Good, so Charlie sees sine squared plus cosine squared, and he thinks one, but he's got these negatives in, so he made it negative. I'm gonna say that you were on the right track, Charlie, but I just want it to be positive one. The negative one will come if there's a negative out front here and here. If both sine and cosine are negative, then it can be negative one. But since I have sine of some angle plus cosine of the same angle. I know on our paper we said theta can equal negative x. Theta could equal 50. Theta could equal 17 pi. I don't care what theta equals, but it's the same. So sine squared of an angle plus cosine squared of an angle is simply 1. Okay. Let's look at the next one. All right, secant squared, these should both be of x. I don't know why it looks like it's not x. Make it all x, x. Secant squared of x minus tan squared of x over cosine squared of x plus sine squared of x. Do we have any of that on our identity sheet?
Yeah, secant squared minus tan squared is 1.
Oh, nice. What about cosine squared of x plus sine squared of x?
Also 1.
Why is that also 1?
Because it said it on the sheet.
Well, it doesn't actually say cosine squared plus sine squared. It says sine squared plus cosine squared. We can, does anyone remember what that property is when, like, in addition, it doesn't matter which one you say first or second?
Commutative.
Commutative, very good. What's 1 over 1? 1. Wow, those were some easy problems. All right, we're gonna do one more like this. We're not gonna do G today. I just don't feel like it. We're gonna do letter F, and then we're gonna do some slightly different problems. Section 5.2 uses more of this, and I'll probably put a practice worksheet online too if you want a little bit of extra practice on what we're doing right now. So let's look at this next one. I'm not gonna fully set you free yet. I want to, but I'm a little nervous, and I don't want my little baby birds to fall to their death. So we're gonna do this one together. Any thoughts on how we start?
Change the secant and change like cosine and sine.
Good. Let's get our secant and tan in terms of sine and cosine, okay? So I'm just gonna carry that 1 over sine squared down by itself because he's already in terms of sine. Secant is what in terms of sine and cosine? Sine or cosine? 1 over cosine. Don't forget your square because it is a secant squared, so just carry those squares on through. What about tangent squared? Tangent squared is good. Sine squared over cosine squared. What should I do next? Yeah, let's get rid of this big ugly fraction, right? Let's deal with this. And I'm actually gonna deal with that off to the side so I don't have to mess anything else up. I'm gonna come over here and I'm gonna do 1 over cosine squared x times the reciprocal, so it's gonna be cosine squared over sine squared. All right, cosines are gonna cancel. I'm left with 1 over sine squared. So I'm gonna come back into my equation. I'm gonna take out that big pink ugly fraction and it becomes 1 over sine squared. So I've got 1 over sine squared plus 1 over sine squared. That's pretty cool. Can I add those two together? What would that be? Good. Sometimes we do such tough things that then we get to literally 1 plus 1 and we forget that that's just 2. So 1 over sine squared x plus 1 over sine squared x is 2 over sine squared x. I do want to go one more step. I don't really want sine in the bottom. When sine's in the denominator, what's that the same thing as? Which trig function is that? Cosecant. So this is like 2 cosecant squared x. Whenever that sine's in the bottom, I can flip it on top and make it cosecant. Like final answer. All right, you guys are doing awesome. We feeling okay? All right, these next few are actually good unit circle practice problems, so I'm glad that we're gonna do these together. These problems say, solve, and it says the answers are between 0 and 360, so that means I want my answer in degrees. We're doing, inverse trig problems. And we've done a lot of practice with, unit circle. If I give you the angle, you give me the fraction. Now we're gonna go backwards a little bit, so this is gonna be good. Good little practice. Okay. The first one says 2 cosine x sine x minus cosine x equals 0. All right, that's disgusting, right? How do we simplify that? What can I take out of both of those pieces? A cosine. I see a cosine x in both of them. So let's factor that cosine x out. So I'm gonna say cosine x, and then I keep in parentheses 2 sine x minus. If I take a cosine out of cosine, I'm left with just 1. Okay, cool. Let's do a little sidebar, okay? Sidebar. If we had an equation where like x squared plus 2x equals 0, and then we factored an x out, what would I do to know what my answer for this is? Like, how would I solve this? How would I finish? Give me one more step before you start subtracting twos. Andrew? Good. Technically on these, there's a property in algebra that we learned a long time ago, so you just naturally do it. When you have it factored out, you can set each factor equal to 0 and then we can solve, right? You don't need to do this little example off to the side. What we're gonna go do on that problem is we're gonna go set each of those pieces equal to 0. So that cosine x is like that x that we had factored out. I'm gonna do cosine of x equals 0. And I'm also gonna do 2 sine x minus 1 equals 0. And we're gonna solve those. Okay. When I see a problem like this, what I want to find is my x. So I'm asking myself, okay, what angle has a cosine of 0? What angle has a cosine of 0? Remind me, cosine is x or y? X, good. So what angle has an x of 0? 90, good. And what else? 180. Not 180. 270. 270, good. That's all right. That's what we're practicing. 90 and 270. Awesome, okay. So my answer that would work here would be 90 or 270. Now we have to do the 2 sine of x minus 1. So let's get sine x by itself so that we can ask ourselves what angle has this sine. Let's add that 1 to both sides. 2 sine x equals 1. Let's divide by 2 on both sides. Sine of x equals 1/2. Remind me, is sine x or y? Y. So now I'm asking myself, what angle has a y or a sine of 1/2? 30. 30. 30 has a y of 1/2. Yes, I agree with that. Now, where else is there a positive 1/2 on our unit circle? What other quadrant is it? Quadrant 2. So then I want the 30-degree angle in quadrant 2. That's 150. All right, so that's all we're doing. We're gonna do one more like this. I'm sure we won't get to the other ones like it today, but that's okay. I'll make a video on it. They're the exact same type of problem, except that they are needing radians. So the answer will just be in radians instead of degrees. We'll just finish these little bits. There's one couple calculator problems. This is what your video will be on the next day. Okay, so let's finish letter B and then we'll call it a class. Just like the one above, can we take anything out of both of these terms? Take that tan x out of everything. Now that root 2 might be troublesome to us, but if we remember, our unit circle has square root 2s, has square root 3, so I'm not really that worried about it yet. Now what do? Good, set each equal to 0. So I've got tan of x equals 0, and I've got square root 2 cosine x minus 1 equals 0. All right, tangent is what in terms of x and y?
Whatever.
Good, y over x, and we know cosine's x. I'll come back to cosine in a minute. So I'm asking myself, okay, what angle has a y divided by x of 0? If y divided by x should be 0, which one should be 0, the y or the x? The y should be 0. So what angles have a y of 0? 0?
180.
180. Good, we're actually not gonna include 360 because it has a little parentheses around it there. We're gonna just say 0 and 180. Right? Now we're gonna have to simplify that cosine one a little bit so I can solve. So I'm gonna add 1 to both sides. I'm gonna have √2 cosine of x equals 1. I'm gonna divide by square root 2. So I get cosine of x equals 1 over √2. Ooh, I can't think of any 1 over √2s on my unit circle. Can we rationalize that so it makes sense in our heads? Multiply by √2 on top and bottom. So I get √2 over 2. Okay, so now I'm asking myself what angle has an x or a cosine that's √2 over 2?
45.
45, good. What other quadrant will there be a positive?
4.
Good. What's the 45-degree angle there?
315.
315. So I'm glad we got to practice this because this is good stuff to know for your quiz next, or your test next week. Okay. Again, I will make a video to finish these notes, and you need to complete the notes and do the 5.1 homework by the next time I see you, not the day of the test, the day after that. I truly don't know what that day that is, but I'll put it on Schoology, and so you can make sure that it's done by then, okay?
Let me turn this off.